Hi everyone. In today's video, we are going to implement Saga Pattern. This is a complete end-to-end example of how distributed transactions is handled in microservices. We build a backend in Spring Boot microservices, Kafka and Postgres, and then connected with Angular UI. Distributed transactions are the major challenge in microservice architecture. Often, business process span into multiple services. Consider service 1 calls to service 2 and it calls service 3. Every transaction requires multiple services to accomplish. Asset property, atomicity, consistency, isolation, and durability. This is a traditional database attribute. This asset will not work when across the services, when transactions span across multiple services. In microservice architecture, each service will have its own database. Any transaction will be local to its microservice. Now, eventual consistency is expected across services in order to maintain the consistent data. What if some other service getting rolled back? Service 2 is getting rolled back, and how the information will be passed to service 1? How the data will be corrected on the service 1? Let's address these distributed transaction challenges with Saga Pattern. Saga Pattern. This helps to solve the distributed transaction issues. Now, business process filtered into a local transaction. It means a service 1 will have its own database and the transaction will local to the service 1. The same way, service 2 also having its own database and the transaction will be local to the service 2. The commit or rollback is responsible for each service. Here the services are coordinated via the event or the orchestrator. Let's talk about the choreography Saga, in that case events. Each service communicates with other service via the events. In case of a failure in a transaction, a compensating event will be triggered and another service will read the compensating event and act accordingly. So the eventual consistency is maintained as well as the transaction is handled successfully. Let's talk about the Saga Pattern implementation styles. One is a choreography, another one is orchestrator. In case of a choreography, it is event-driven and there is no central brain to control the services and each service should react to events. On an orchestrator, a central orchestrator will be there and that will be controlled the other services. However, it is easy to trace, but it adding coupling to the services. Let's take a use case. A simple e-commerce where customer sends order and it depend on the payment and inventory. Let's go for the data flow. You're receiving an order and you will be checking for the payment. If payment successful, then we'll be checking for the inventory. If inventory also available, we'll confirm the order. If payment is failed, we have to cancel the order. If inventory also not available, we cancel the order. Let's implement this use case with the help of a Saga Pattern microservice. These are the overall components we are going to build. Let's start with the services. Will be in a Spring Boot, order, payment and inventory. Kafka will be the event backbone of this application, and we have a database Postgres for storing the order and NoSQL for inventory. UI will be in Angular. The flow is expected. Order service will receive the order, and payment check for the payment, and inventory check for inventory and reserve the inventory. Finally, we'll receive the order result. We have 3 services and 5 Kafka topics. Order service receives the order request. Order service will publish the order created message in the Kafka topic. Now payment service consumes the order created message with order information. As per business logic, payment service trying to authorize the payment. On successful payment process, payment service will publish the success message to the payment authorized queue. Order service is a consumer of payment authorized topic. It receives the successful payment about the order and updates in the table. We are maintaining different topics for different kind of an event. In case of a failure on the payment, the failure transaction, the payment details published in the payment failed queue. Order service is a consumer of this topic and notifies the failure of the transaction, and the order information is getting updated on the database. So far we understood how the order flow between order and payment services. Now let's talk about the inventory. On the successful of the payment authorized, inventory consumer receives the order information and the successful payment information. So the inventory service will try to resolve the inventory. If it is able to successfully resolve the inventory, it publishes the success message on the inventory resolved queue. Now order service consumes the success message from inventory and confirm the order as payment and inventory is completed. If inventory failed to resolve the inventory and publish the failure message to the inventory topic, order service receives this failure information and confirm the cancellation of the order. Let's start our implementation. So as we know that we are going to create 3 different services: order, inventory and payment. Now we are going to start with the order service. To talk about the order service specification, it's a Spring Boot project, and it is having the dependency of the Postgres and the Kafka. So now let's going to implement the order service. In this order service, I'm going to expose two different endpoints. One is for creating the order, another one is for tracking the order. It starts with the controller. So let me create a controller package and order controller. So this is a REST controller. So we are going to expose two different endpoints. So I'm going to create two different methods. So now we set it to two different endpoints. One is the create order, another one is the get order. Order should accept the payload. So now we are going to design the payload for create order endpoint. So that I am creating a model package. So let's create a record. So in that what I'm having string customer ID and big decimal of amount, and we have the items. Name of the item, quantity, and amount. So now create order request. I created a record instead of a Pojo with a lombok. So I created as a record. So now I'm ensuring the customer ID and amount is not coming, is not null. Now on this controller, so the request body, I'm accepting the create order request now. Creating the domain object and associating to a entity and the repository. So now we'll start with the domain. So we created we are associating this domain object with the table orders and ID. So ID will be automatically generated, and we have a customer ID, and let's start creating the status. So status is going to be the enum. So order can be created, could be pending, completed or cancelled. Now so the default value assigning it's pending. Whenever you create an order, it will assign with the pending status. So now amount. Now we are going to associate order with the order item. So now here we have to make a parent-child relationship. This is the parent and that is the child. So first we have to give us. After doing that, we have to generate the getters and setters. So I'm generating. So instead of the set item, in this item domain entity, so now I'm making the join between this order and order items. And generate the getter setters. Now let's complete the order domain. In this order domain, we have to set mapped by is equal to. In this order domain, we have this field that is going to manage the foreign key here. So it's mapped by the order domain in order item domain class. So we are done with the designing this two different domain. Now we are going to create the repository. On this repo, I'm creating a interface order repository which extends GPA repository of order domain, and the key type is long. So our repository is ready now. So we created a domain object and associated to a table, as well as now we created the repository. Since we are going to use the basic functionality of the repository like a create and fetch, so we are not adding any more feature here. To work on the service layer, in this layer we are going to convert the request into a domain object, and using the JPA repository we are going to save data in the database. Let me include the repository. Using a constructor injection, I'm including the order repository. Now we are going to convert this request into a domain object. So in this domain object, so now we converted this request into a domain object, and the domain object we are calling the repository dot of the domain object. So this line will insert your requests into your database. Now the ID will be generated on the domain. So now we have to return this into a response and check whether our item getting inserted or not. Just a quick check. So here I am returning. And the controller, so I'm returning a string, and so whatever information is saved, we are just sending the ID to check whether our API is working or not. Now we are going to start the server and just check whether our code is working for insertion of the record. Let's start the server. And the server is running on 8081. So already I prepared a request. So the customer ID C1, that is amount, and I'm adding a single item. Let's check whether it is returning the customer ID. Yeah, we got the customer ID. So multiple customers are getting inserted. We are not verifying the customer ID duplication. So now let's check the database. So the items is getting inserted. So successfully our items are getting inserted in the database. Since we are implementing the Saga pattern, so now we have to emit an event from order service. That order is created, right? Now we have to create the publisher components. So I'm creating a publisher component. Order publisher. So for sending a Kafka message, we need a Kafka template. So the Kafka template will be injected while creating this publisher component, since we are using the constructor injection. So the Kafka template help to send the message to the Kafka topic. So now we decide what is the topic name and what is a key and what is a message. Since it's a very small application, so now we can define our own topic here. So I'm hard coding the topic here. Order created. So now we want the order information that is from the service layer. So we know the order ID. So the same order, I'm passing the key and value as the same value, which is going to be the order ID. The message could be order created. So from service, we are going to call the publisher. On successful of save, we have to publish the information on the Kafka topic. Yes. Let's test this particular portion of our implementation. Let's run this application and check whether the messages getting posted in Kafka successfully or not. Before that, I'm just showing the list of topics. As of now, I don't have any topics created here. Let me run this application. Let's change the customer ID and hit the service. So since we received the order ID, and let me check whether the message getting posted successfully or not. Now if you can see, the order created topic is created. Let me see whether the message is received or added in this topic. Let's try to retrieve the message from the topic. So for retrieving topic, hyphen topic, and the topic name is order created. Yes, we receive the order message and the key will not be displayed here, and we see only the message in the Kafka topic. Yes, now since so far our implementation worked well, we can able to insert record in the database, as well as we can send a message to the Kafka topic. As part of a Saga pattern, this order service emitting an event to other services that the order is created. We are sending a very simple message, order created. So whatever message, whatever service receiving this message will not know much information about the order. Only it has the order ID. Since each service uses a different database, it will not have much information about the order. So we have to send some more information about the order to the other services to take appropriate action. Now let's send a model object of an order to other services. To do that, let's define a model here. Now from domain object, we'll convert it into a model object. From model, we can generate the JSON string. Since the quantity information stored in each item, let me declare now we want to convert this particular model into a JSON string. So here, actually I'm handling the suppressing the exception, but this will not be the case on the production grade applications. Since it's a simple demo, so I'm suppressing the exception and printing all the stack trace. This is not a good practice when it comes to the production environment or any live application. So application and check the consumer messages. So the message, so the order is created. Let's run the consumer. Yes, now see, the order ID is 8 and the amount, customer ID and the quantity. So the JSON is deserialized and sent as a payload in the event. Let's test one more time. So we are successfully receiving the seeing the message on the Kafka topic. Now let's write a consumer in the payment service. Now our topic is order created. We have a single group, so we are not specifying the group ID here. So the consumer message will be let's test this consumer. So now what we did, we created a consumer in the payment service. So whenever a message published in this order created queue, that will be consumed by this payment consumer. So now we are just displaying the record value and the key. Let's test this particular piece of code. So now we have to run both the application. I'm starting the order service. And now I'm starting the payment. So payment going to be run on 8082. So since we configure from beginning, means earliest in the sense from beginning we receive all messages. Now we see we consumed the message, means the order information and the key. So now let's create another order. Yes, it is created and it is received in payment service successfully. Let's fine tune this consumer. First we are going to unmarshal this particular payload. To unmarshal this payload, we need the order detail class. So what I'm going to do, I am going to copy this. So the order information is pasted in payment service. So ideally, we have to put this particular class in a common module. Then that module will be shared across order and payment. Since it's a demo project, I am replicating this Pojo, this model in the payment service. So now in this consumer, we are going to serialize it, deserialize it. So now what we are going to do is, in some scenarios we have to accept the order, in certain scenarios we have to reject the order, like payment failure. We are not going to integrate with any third party or any payment interfaces. What we are going to do, we simply validate the amount. Let's say if it is less than $1,000, so we accept, or we say that the payment is authorized. Otherwise, we'll say that the payment is failed. So we are going to handle that particular use case here. In case if the amount is less than certain value, we will be sending a message that payment is authorized. Otherwise, payment is failed. So we are going to implement this particular use case here. So now So if the order amount is less than $1,000, we are going to say that the payment is authorized. So obviously what we are going to do, we are going to create a new topic that is called payment authorized topic, and we will write this particular order information on the topic. Otherwise, we'll create another topic called payment failed, and we will be writing this order information on the payment failure topic. So in order to handle such scenario, we have to include Kafka template. So now Kafka template is available. So I am going to publish the message on the Kafka template. So first will be the topic. Let's say payment, if it is less than 1,000, payment authorized. And we are passing the key as the order ID, and payment failed due to amount limit. So it is a very simple use case. If the amount is less than 1000, we are saying the payment is authorized. If it is greater than 1000, we are saying the payment is failed. Now what we are going to do is we are going to update the order status. Let's say if it is authorized, I'm making order as completed, otherwise order is cancelled. Since we are having two different topics and we can segregate this order status separately. So for that I need to create a service update to the order status. So now what we did is it's an auto-generated code for update order status. We have to send the order status and the order ID so that we can find the item and we can update the order status. So now we can update here. Before that we have to inject the order repository. In case of a successful authorization of the payment, I need to inject the order service. In case of a failure, I'm making as order as cancelled. So now we are handling the compensation event. If the payment is failed, we are cancelling the order and we are updating the order status. And now we have to fill the get order also. So in this get order, we have to repository. We have to send the order status, so I'm updating this model with order status information. And quantity, we have to find the quantity. order slash the order ID will get the order information. So what we are going to do, we will submit the or we create a order request, and then we'll see how the order is getting completed by the payment service. So let's run this application. So my order is 14 now. So order slash 14, I'm getting 404 path variable. Let's start the order service. Now let's start the payment service. So both the services are up and running. Let's check with the new customer ID. So my customer ID is created. Let's validate any exception, or there's no exception on both the sides. Now let's try to get this order ID 15 in the get request. Let's fix this fetching of order items. I'm changing it to eager so that it fetches order with the items. There are different solutions are available for lazy fetching, but for time being we go with this eager fetching. So let's start the order service, followed by the payment service. Now we create another order. We got the order ID. Now let's put 16. Now we see the order is cancelled because the amount is greater than 1000. So let's create another order with less value. So order is created, and you can see it is 17. 17 is get completed. So you can see now how the services are communicating and how the transaction is handled here. Order service creating the order and publishing the message on the topic, and the payment service consuming that message and processing the transaction. And based on the payment service result, again order service making the transaction as completed or cancelled. So this is a typical Saga pattern implementation. So in Saga pattern, we are focusing on the compensation event. In case of a failure, how we are going to handle the transaction gracefully. If the transaction is failed, the compensation mechanism will roll back the necessary data changes in your database. So this is how we are implementing the Saga pattern here.